Awesome. Hey everyone, welcome to this first episode of our video series where we will be deploying Nomad on Google Cloud. I'm accompanied by a friend and co-host and former colleague, Chris Terbeke. Chris, why don't you introduce yourself to the audience?
Hey, thanks, Bruno. Yeah, so I'm a Google Cloud expert for about 10 years already, and today I'm going to help you to show how to deploy Nomad on Google Cloud.
Exciting. Okay. And in this first episode, we're briefly going to touch upon some networking magic that we already set up prior to this stream, but we're mainly going to focus on deploying servers and clients, Nomad agents. If you have any questions, feel free to interact with us in the chat. Chris and I would love to answer your questions. But let's dive into it, Chris.
And yeah, let's go ahead.
Yeah, and we're going to use Terraform to deploy everything on Google Cloud. So Chris and I already went ahead and set up a Git repository, and we added a couple files in there. I'm going to briefly walk through what we did. These are just prerequisites that you can set up on your own whenever you're going to deploy Nomad. They're very basic things like setting up a provider or setting up a backend, for instance. And here's our provider definition. We pinned it to a particular version, of course. Then we also set up a vpc.tf. And this might look a little bit intimidating. We're going to do a bonus episode on how to set up all the networking bits and pieces. The way we've set it up, networking is very specific, and there are a lot of requirements to it. We can spend several hours talking about this, but I'm going to briefly walk through it to give you an idea of what we've set up prior to deploying a Nomad cluster on Google. So our first resource is just a compute network. It's a global network. We created a subnet as well. We called it Nomad. We gave it just any other IP CIDR range for the sake of this video series. Of course, we're attaching that subnetwork to a network, and we're setting up private IP Google access. Chris, can you briefly tell the audience what this is?
Yeah, so Google has a bunch of APIs to deploy resources, and usually those are called over the public internet. But in a fully private network, you cannot often reach the public internet because there are no routes or there's firewall rules preventing that access. So Google exposes a bunch of private IPs that you can connect in your internal private network and still reach those services in order for example, your virtual machine to access another Google service.
Yep, right on. Awesome. And the resource below that is a firewall rule where we're basically allowing our network to have access to private Google access. It's an egress firewall rule. Below that, we have another firewall rule for restricted Google access. Google has both private Google access as well as restricted Google access. And the IP ranges are declared on the top of the file in our locals, line 4 and 5. If you scroll up all the way, Chris, then they are there on line 4 and 5. So if we're going back now down to our firewall rules, we also have a couple of routes. Firewall rules are one thing, but routes are another. Routes are essentially like your paths, and firewall rules are your gates. So in order to make traffic flow from one point to another point, you need a route, and you need a firewall rule to allow or deny that. So this is a firewall rule for private Google access, and this is a route for private Google access, and this is a route for restricted Google access. Now, to make all of that routing possible in a private network, we need also private DNS. So we created several DNS zones, which are declared all the way on the top. So if you go to the locals again, we created a DNS zone for package dev, which is here. We created a DNS zone for GCRIO, which is for container registry and artifact registry. And for googleapis.com, this is because we want to be able to route traffic to those private Google APIs. So if you go back down to the DNS zone, yes, so this is how I'm using a for each here to iterate over that map, and then I iterate over those 3 DNS zones, and we're here creating those private managed zones. And for every private managed zone, we set up a CNAME with a wildcard in it, and we create a couple A records, which are the IP addresses that you can find on the Google documentation to be able to route to those package dev, GCRIO, and googleapi.com URIs. And in order to make traffic, because we're going to deploy a Nomad cluster, those agents are going to boot up and they're going to need to be bootstrapped. They'll install several packages, and therefore we need access to the public internet. Chris, do you briefly want to explain the audience how you would go about accessing the public internet?
Yeah, so for machines in a private network, they don't have a public IP. You need to route them through a NOT gateway so that they are able to access addresses on the public internet. So for that, we're setting up a compute router. We reserve 2 public IPs, and then we connect the NAT gateway to that router. And this allows our private VMs in our private network to access the public internet, but only in a very restricted way, because we only allow access to specific addresses, which you will see in a little bit.
Cool. All right. Thank you for that, Chris. Now, added, we also have a quad 0 route. This is just a route that is there in order to be able to communicate. I made a typo here. In order to be able to communicate with the public internet. Now, below that, we also have an internal ingress rule and an internal egress rule. Let me highlight those real quick. And these allow machine-to-machine communication within our network. So not necessarily outside of the network, but within our network. Then we also have a safety net. I think this is always a good practice to employ in any Google Cloud project where you set up your own network, to set up a deny all egress rule with a priority of 65,534. That's the highest number of priority that you can give. It's actually it's a little bit weird, but in Google, the higher the priority, the later it will be evaluated when multiple firewall rules are being evaluated. So think of this as your safety net that you deny by default and you allow explicitly through other firewall rules. So that's that on a denial egress rule. We also set up a compute network firewall policy. And this firewall policy is attached to a service account on line 270. Let me highlight that real quick. And this is we created a Nomad agent service account. We only created the service account. We haven't used it besides in this resource. We're going to use it in this episode to deploy agents and servers with, clients and servers with. But every client or server needs to be bootstrapped when they're being deployed and they're becoming part of the cluster. They need to install several packages. And in order to be able to allow traffic to the public internet to those specific URLs, like releases.hashicorp.com to pull a particular Nomad release from, or some Ubuntu FQDNs, we are creating this network firewall policy rule here that is allowing certain destination FQDNs, and if they match, we allow traffic to that over TCP. And of course, it's egress traffic. So that's the firewall policy rule, and then we need to associate it to the network. That's this Google Compute Network Firewall Policy Association resource for it. Did I miss anything regarding to networking, Chris?
No, it's all here. It's all in a single file, so neatly contained.
Awesome, cool. So what are we going to do next? We have our network, but I guess it's time to start deploying the actual Nomad cluster.
Yeah, so as you might know, Nomad is a workload orchestration platform, and workloads run on virtual machines eventually. And Nomad ensures that they are correctly scheduled across all of your virtual machines. So within that, Nomad runs, it's a single binary, which contains an agent runner. And this agent can be configured as either a server, sort of an orchestrator, or a client. And a client is a VM that workloads will actually run on. So let me show you a little bit of an architecture here. This is from the documentation on the HashiCorp website. So they explain it quite simply here that you have a set of servers. I always in a production environment, which is what we're preparing for here. I recommend to run at least 3 because this gives you high availability in case one of the servers fails. You still have the other 2 up and running and your workloads are not impacted. And they can also elect a new leader automatically when the leader server goes down. And also on the client side, you can have several clients. Also, I recommend here at least 3, also spread across several availability zones if you're working in a public cloud to ensure the highest possible uptime for your workloads. So today in our private network in Google Cloud, we are going to deploy these servers and clients. And we're going to do a little bit of configuration on the VMs to make sure that Nomad runs in the configuration that we want.
Cool. That's super exciting. And thanks for the high-level overview. That really helps. So from my understanding, we're going to deploy instances. Is that correct? We're going to deploy individual VMs that together make a cluster. Is that right?
Yeah, so there's a couple of ways you can go about this. There is this pattern sort of in the cloud native industry where we say we want to treat servers like cattle instead of pet. And that really means that instead of managing individual servers all the time, you're going to consider them like one big group of cattle, and they're all pretty much the same for you. And it doesn't matter if you have 10 or 20 and you scale them up and down all the time. So instead of deploying specific instances on which we deploy Nomad server and clients, we're actually going to make managed instance groups. And this is a feature in Google Cloud that allows you to have a sort of a template virtual machine, and Google can then scale it up and down for you depending on the workload that you require. So we're going to have 2 managed instance groups today, one for the servers and one for the clients, because they both have slightly different requirements. So slightly different configuration and also different scaling requirements. So I think it's a good idea to have 2 managed instance groups. And we're going to put them both in our private network so that everything can talk with each other, which is quite important for a Nomad cluster.
Cool, exciting. So I heard you say a couple times Google Managed Instance Group as well, meaning I'm going to assume there's going to be a Terraform resource for that. We're going to type out some new Terraform files and deploy it. Is that right?
Yeah, absolutely. Like any other Google resource, pretty much the Managed Instance Group and all the sort of configuration resources around that all have Terraform implementations. So everything we'll do today will be in Terraform in code, easily reproducible and documented for everyone to sort of replicate or set up.
Awesome. And am I correct that we're going to have to set up the servers first before the clients?
Yeah, so I think the best order of operations here is to configure and deploy the servers, and they will sort of find each other and they'll be ready to go. And then we can also deploy the clients and they will find the servers and allow workloads to be scheduled. If you do it the other way around, you can run a client, but it can't talk to the server and it's really just sitting there doing nothing. So let's start with the servers.
Cool. Okay, I'm going to create a servers.tf. By the way, Chris and I have a shared workspace in our editor. So you'll see us type and do things at the same time. So I just created a servers.tf, and I think we're going to create a Google Managed Instance Group. And you said that a Google Managed Instance Group needs a instance template. So let's start by creating an instance template. I'm opening the registry on my screen so I know which arguments to pass and such.
That's a good idea. I always use the Terraform registry documentation when I'm
nice
building new resources.
Same here, actually. So we're going to give it a name prefix called Nomad Server hyphen. That is actually going to be postfixed with some random number. Project is local.project. We actually created a locals.tf here where we set 2 arguments in, a project and a region. Because we're using these.
It's my favorite region.
Yeah, indeed, same. We're both from Netherlands, so we must pick that, right? But we do this in a separate locals.tf because we're referencing these values quite often. Yeah, that's that. Instance description, let's just call it a Nomad server. And then machine type. What's a good machine type, Chris?
Well, there's a bunch to choose from. In this case, we're not really sure about the specific requirements yet. So I would just go for the standard machine type, N1 standard one. Yeah.
Okay, sure. That sounds like
we can always change this later. Again, it's all cattle, so it's easy to update things.
Nice. I really like that analogy. Let's give it some tags, actually.
Yeah, so if you worked with Google Cloud before, you might have used tags in the past. And usually they are there to sort of indicate, for example, for billing purposes, what belongs to what. In the case of our Nomad deployment, they're actually going to be functional as well. Because like I said before, these servers and clients, they need to find each other in our private network. And they are going to call a Google API to automatically configure the discovery process. And in that process, it will use these tags.
Okay. So we're also going to give it a disk. And it's going to be, what are we giving it? I think an Ubuntu image, right? That would be likely the easiest. I know there's Ubuntu OS Cloud. I quickly got to Google what the name of the image is. Do you think using Ubuntu is good?
I think Ubuntu is fine. It's pretty full-fledged operating system. You can there's some alternatives on Google, like more cloud native, but those are often very restricted in which packages you can install as well. So I think we might run into some problems if we do that.
Like
so
for instance,
go for Ubuntu.
Yeah. Would that be like container optimized OS you're talking about?
Yeah, so if you use an alternative orchestration platform like Kubernetes, I've used it a lot in the past as well. Although it's very complex and there's a lot of options, it operates on a operating system called container optimized OS, which literally can do one thing. It can run containers for you. Nomad can do much more, like it can even schedule binaries or Java applications.
Yeah.
So I think we should not choose such a restrictive operating system here.
Exactly. And I'm putting a life cycle on this instance template for a good reason. Would you like to elaborate a little bit?
Yeah, so if you change the instance template, Google doesn't allow you to update it while it is in use by actual running instances in your instance group. So if you're going to change your instance template, you want to create a new one and then use that new template on your new VMs that are going to be updated, and then you can destroy the old one.
Okay, so I'll put a comment on it for clarity. So instance templates cannot be updated after creation. In order to update the instance template, we will, or like Terraform will destroy the existing resource and create a replacement. Ooh, okay, great. Now, so we just created an instance template. We added some metadata to it for like enabling OS login and Google logging and blocking project SSH keys. We attached a disk, we're attaching it to the network, and we're giving it a service account. But of course, whenever this server now boots, it's going to just boot an Ubuntu, a base Ubuntu image. But we need to do certain things, right? We need to install Nomad and do all kinds of things. Is that right?
Yeah, so we want to add some automation probably, because we don't, every instance that is being created, we don't want to SSH into it or something like that and manually install and configure Nomad. That would not be feasible.
Yeah.
So I think we should add some automation to automatically do all of the steps needed to sort of become a Nomad agent and join the existing cluster.
Right.
And that is something we can do with a feature called Cloud Init, which allows you to run scripts and configuration items after a virtual machine has booted into the user space of the operating system.
Right. So I'm familiar with Cloud Init, meaning we're going to, I guess, create a Cloud Init file and give it to the user data argument in our instance template. Is that correct?
Yeah.
Should we create a Cloud Init file?
Yeah, that's the easiest way to do this. So that would be a YAML file indeed, where you sort of configure what is being run after boot.
Yeah, I just created one indeed. I know a little bit how to write out the syntax for those Cloud Init files, so that's going to help me not having to Google it. I guess package update and package upgrade are going to be set to false both.
Yeah, I think that's the best option here. We don't want our machines to automatically update and upgrade all sorts of packages anytime a new one is created. This is something we really want to manage in our instance template instead. And Google also manages a lot of this for us because our operating system is patched automatically by Google. So.
Yeah, exactly. So I guess we need to create so think it out loud. We're going to install Nomad, meaning we need to download a release from the release.hashicorp.com API. We're going to unzip that, and we're going to create a Nomad configuration file.
Yeah, so if you look at the Nomad documentation, it literally indeed tells you to download Nomad binary and put it somewhere on your operating system where it can be executed. And then in Ubuntu, we have our systemd environment where we can automatically start, stop, and enable Nomad as a service on the operating system.
Okay. So I'll create a run cmd called install Nomad sh. Are there other things that we need to do besides installing Nomad, as in like configuring certain things on OS level for Nomad to run properly? Are you aware of that?
So Nomad really likes some system configuration to be in place, setting some nice limits on file system operations, for example. So I think this is something we should do before we install and run Nomad.
Okay, like an init script. Okay.
Yeah.
init.ash. And are you aware of those limits that we have to configure, or can we Google that somewhere?
Yeah, so they are in the documentation where you can just sort of copy there's like a couple of commands. Shall I copy them in this file for you?
Yeah, go for it. Yeah. I guess it's going to be like setting some max mapping count and some file related things.
Yeah, it's pretty easy. So here we go.
Okay.
See, we need to prepend this block as well with the right files.
Right files, right? Yeah. Right on. Nice. Then I'm also going to almost. Right. I thought this was okay. Right files.
Yeah, I think it's complaining about your
spaces versus tabs.
Yes.
Interesting. Okay.
We'll format the file, hopefully.
What does it need?
I think it's using spaces. Not sure.
Oh, interesting.
What's going on?
Okay. Anyways, I'll meanwhile, maybe you can fix that. Meanwhile, I'll set up the other one, which is to install init Nomad. Install nomad.sh. We also need to tap that. And it's also going to get the same permissions. And we're going to give it some content. Oh. So we're going to do a curl command first to install from the releases API. So that would be https releases.hashicorp.com. Good thing I know this from the top of my head. What is the Nomad version we're going to run, Chris?
Very good question. I think because Nomad gets updated and gets new releases quite often, in this file, let's template it so we can pass it automatically.
We can do 1.8.0. That's one of the releases I'm aware of.
I think that's the current, might be the current version indeed.
Okay, let's just do that. Slash nomad, that would be 1.8.0. And then I think we're going to install Linux AMD. Linux AMD 64.
Yeah, we're using 64-bit CPU architecture here, so that's the correct one.
Oh, typo. And it's going to go to nomad.zip, and we're going to unzip that. Unzip, whatever I just wrote there.
Ah, so that's why you installed the unzip package. Right.
Yeah, indeed. I think that's flag D, and then to opt init, so we get the content there. Then what do we do? Then we should copy over the binary to the bin directory. By the way, all these things we're doing right now are featured in the documentation, which should pop up in the screen right now. Local bin nomad. Chmod plus X. Then we're gonna Chmod. Do you quickly want to explain what I'm doing right now, Chris?
Yeah, so we've unzipped the Nomad installation file, and in there you find a binary file, and we're copying that to our user local bin, which is a pretty default location for any binary on Ubuntu. And with chmod, we make sure that this binary can actually be executed. So we're giving it the correct permissions to run. Because by default, not everything you download is allowed to be executed. Yeah, so then finally we're calling system control CLI tool here to enable and start Nomad automatically when this machine is started.
Yeah.
So which brings me to the next point. I think at this point, if you run this, systemd will complain because this service doesn't exist. So we should create it.
Create a service, right? Yeah, let me go up here and so I think we are also going to do create a service in systemd, right?
Yeah, so that would be in etc systemd. Yeah.
And what kind of permissions does this get? I think that's going to be 0655.
Yeah, that's pretty standard for systemd services.
So please make any corrections if I mess something up in the systemd configuration, okay?
Sure.
I haven't written systemd configs in a while. Let's add a documentation link to it.
Yeah, I think most installable packages on Debian or Ubuntu actually come with a pre-configured systemd file. Nomad does not, so we need to configure it a little bit ourselves.
So we're going to have to create an exec start and an exec reload. And that exec start should be calling the binary that we just moved into the user bin local directory.
So we want to run this binary with a couple of parameters actually. So we want to call the agent entry point.
Okay.
And then we want to pass a configuration file because every Nomad configuration is a little bit different because everyone's environment is different. So here we should actually point it to a config file that we will write in a little bit.
Okay.
Now, like I said before, we're going to have servers and clients, and both have a slightly different configuration because, for example, whether Nomad is in server or client mode is part of this configuration file. So I don't want to retype all of this again. So I think we should maybe template this a little bit to make sure that in our server and client instance templates, we can actually specify whether we want to call the server or client configuration.
Yes, exactly. Okay. So I think what we can do for that is, so we don't have the config file yet, but we can do something like this, I think. Because we're going to template this file, we can also put a condition in it. If it's postfixed by server, then that, and Nomad client, I think we can do the same. Client. Is this correct?
Yeah, it might look a little bit weird right now, but I think once we actually write the Terraform template file syntax in our manage instance group configuration, it'll make sense.
Yeah. Okay, great. Then we also need an exec reload if we have an exec start. And that's
I always like my infrastructure and applications to be as much auto healing as possible. So I think whenever there is any chance that our service can automatically restart, we should configure it.
Yeah. And that's what we do using this one. So with the exec reload, we're basically saying bin kill, and then we give the hub for the main process ID. Restart is always. And then we need an install block, which is wanted by multi-user target, I think. Multi-user.
Yeah, so this is pretty standard systemd stuff. We basically indicate here that this process will only run after sort of our Linux user space is also ready.
Yeah. All right. So that's that. Now we created a config here, which doesn't exist yet. So I think we have to create that file as well.
Yeah, this is also a file we should write. And let's
write.
actually put it above, because then we make sure that this file exists before we start calling it from the other one.
Exactly. Yeah. Oh, I just jumped to the top path. So that's going to be whatever we put here, and then Nomad HCL. Oh, sorry. Nomad.hcl. Permissions for this are going to be.
The Nomad config file is using the HCL syntax, which is very familiar for those who use Terraform.
Yeah. Maybe you can. I'm going to write out the Nomad configuration from the things that I'm aware of. We're going to configure, but maybe you can real time explain to the users what we're doing.
Yeah. So Nomad has a config file, and all these parameters are also documented on the Nomad HashiCorp website. So what we're entering here is a region and data center basically combined. Tell Nomad what the sort of physical and digital location of your virtual machines is. If you have a setup where you run Nomad in multiple regions or multiple data centers, this is where you indicate where these VMs live. And then when we start working on our workload scheduling, we can actually target specific regions or data centers to make sure that everything's correctly distributed the way we want. This is quite important if you want things like high availability across multiple regions. And then we have a data there, which is just a configuration item that whenever Nomad needs to read or write some temporary local data, it goes to this directory. So make sure that this directory exists and that the Nomad system user can access it.
Yeah, and it is good to mention, you probably noticed by now, but we are writing all these files and these server, for example, this systemd service and the Nomad file, the Nomad configuration file we're writing out now, because like Chris said in the beginning, Nomad has the concept of agents, and they can either be a server or a client. We're going to deploy several clients, and we're going to deploy several servers, but we are writing a single Cloud Init file, and we're basically passing things like Nomad server or Nomad server account, certain arguments that we're going to template into this Cloud Init file to prevent ourselves from maintaining two different Cloud Init files. So that's why you will sometimes see this templating syntax here. Just an FYI.
Yeah, that's correct.
Now we're going to set up this server join block here. Would you like to explain this to the audience, Chris?
Yeah, so like I said before, we have multiple servers and clients, and they operate in a cluster. And they need to communicate with each other. And before they can do that, they need to be able to discover where the other servers and clients are. And for that, we are going to use a little bit of automatic service discovery. And luckily, the Nomad project has built-in discovery code for all the popular cloud platforms. So in this case, we are going to configure Nomad to use the Google Compute Engine provider to automatically, in our project, find the other servers with the tag we specified in our instance template. And Google will then return some metadata with IP addresses of these servers, and then Nomad can automatically contact those IP addresses to communicate with the other servers.
Yeah. So this will.
If you run,
oh yeah.
I think if you run it in a non-cloud environment, this is something you would need to either write your own server discovery, or you need to manually specify the IP addresses of all the servers and clients you want to connect in a cluster.
Indeed. So two things I'm picking up from this. One, this Nomad server tag that we created. I think you're following me in the editor. But this Nomad server tag in servers.tf on the top here in this local block that we're referencing, basically we're giving it to every instance for the Nomad servers. Chris in the beginning said this is actually a functional tag. So that is basically doing this. It's making sure that whenever a instance boots up and in the Cloud Init, it is a Nomad server, that we are tagging it as a server, basically, and is then joining the server as a server. The other thing I'm picking up from here is this is that little bit of service discovery we're going to use. We're not going to use Consul. So that means in the Consul block, which we're also going to define, we're going to set things to disabled. Is that correct?
Yeah, so I like simple setups. I think Consul is a great product, but if you don't have a complex sort of mesh kind of networking situation, which we don't intend to use, I think it's better to leave it out for the sake of simplicity.
Yeah.
It is automatically enabled, so this is why in the configuration here, we need to disable it.
Yeah. And we are also going to set up some telemetry specific things, which are going to be relevant for future episodes of this video series. Would you like to a little bit explain about telemetry in Nomad?
Yeah, so Nomad automatically exposes a bunch of telemetry data, which you can scrape to configure alert and logging and other automation. I think in Google, Google natively supports like Prometheus formatting, so I think this is something we should enable. And we probably also want some metrics on node allocation, which is how many workloads are running where, and node metrics. I think these are going to come in very handy when we get to features like auto-scaling.
Nice, nice. So what I'm picking up here is that we are likely going to publish metrics to Google and use that for Google native auto-scaling.
Yeah, we're going to, in a future episode, going to configure our managed instance group in such a way that it automatically scales up and down, depending not only on how much CPU is being used, but also how many workloads are actually scheduled and are waiting for space, so to say.
Nice, nice. And Chris, another thing, we're going to schedule other jobs on this using Nomad, which in the beginning you said you can schedule just binaries or you can schedule jobs using Docker. I'm going to assume that Docker is not default installed on here, or at least it's not set up in like a bridge network mode. Are my assumptions correct? And if so, do we have to install Docker?
Yeah, so if you want to schedule container workloads using Nomad, which is kind of the default way nowadays, I must say, because everyone uses containers, right? Then you definitely need a container runtime. The most popular one is still Docker, and it's pretty easy to install. And there's a plugin for Nomad to properly support Docker, which takes a lot of the configuration hassle away from you. So I think we should go ahead and install that plugin already, because we're pretty sure we're going to schedule some containers.
Okay. So plugin Docker config allow privilege. Would you briefly like to explain what the allow privilege is?
Yeah, so this basically allows Docker to run containers under the root user. Yeah, this is quite important if you run specific types of workloads that, for example, need to access specific features of the host operating system. Because we have full end-to-end control over our environment, and in the host we can also specify the security policies. I think this is okay to do.
Okay. All right. So on the top of the file, next to curl and unzip, we're going to install Docker IO. Docker IO. And I guess we're going to need to set up some bridge networking as well. Or am I
So
wrong?
I think maybe in the next episode, when we get to more networking and container networking within our Nomad cluster, we're going to do some stuff with the CNI plugin. But for Docker to probably run, we already need bridge networking in place. So I think let's go ahead and make sure that our bridge configuration is okay.
Okay.
And these are literally just a couple of IP table rules, so it's not very difficult.
Yeah. I gotta Google this, to be honest.
So yeah, we just basically need to make sure that our IP tables for IP, IP6, and ARP are configured to accept bridge networking. I can copy. There you go.
Yeah, so I got the ARP tables set to 1. I got the IP6 tables set to 1, and the IP tables set to 1.
Yeah.
Alrighty.
Yeah, it's pretty transparent networking.
Yep.
Don't need to make it any more complex.
All right. And I'm adding this Cloud Final modules, which is always part of that Cloud Init I make. And I'm going to put in there package update, upgrade, install, always. And I'm going to enable scripts users.
Yeah, this basically tells Cloud Init to always run these types of stages. So, for example, the run commands, which are part of our user scripts module, and all of our files and package installations, which are part of the package update, upgrade, install stage. We need to make sure that Cloud Init actually executes these.
Awesome. So could you quickly recap, Chris, what we just did in this Cloud Init file?
Yeah, absolutely. So yeah, Cloud Init is a way to automatically configure virtual machines in a cloud environment. So in our case, we are going to install a bunch of packages that we are going to need in our scripts to install and configure Nomad. We are creating a file to tell Nomad how to configure itself. So for example, the region and data center parameters, which are quite important if you want to schedule workloads in specific locations. We are going to schedule or configure our server. We are configuring retry join, which ensures that our servers and clients can automatically find each other within our network. And for that, we are using a built-in Nomad Google Compute Engine provider. And we are going to use the tag that we configured earlier in our managed instance group template so that all of these machines can automatically find each other. We are going to disable Consul because we're just not going to use it for now for the sake of simplicity. We are going to enable UI because it's always nice to look at a few things to see what's happening. And we are going to install the Docker plugin because we're pretty sure we're going to schedule container workloads at some point. Lastly, we also want the telemetry configuration to expose telemetry for allocation, so which workloads are running where, and for our nodes, which are our Nomad agents and servers, And we are going to enable the Prometheus format. And these three will help us to communicate between Nomad and Google Cloud to automatically scale up and scale down our managed instance group, depending on CPU usage, but also how many workloads are actually being allocated. We're setting up some bridge networking, which is needed for Docker and the container native networking interface. We are adding a systemd service for Nomad so that it automatically enables and starts when the virtual machine starts. And we are doing some file system configuration that Nomad expects. And we literally just grab this from the Nomad documentation, so it's pretty easy. You don't have to come up with this by yourself. And finally, we are going to run a script that actually installs Nomad from the HashiCorp official releases URL, unzip it, put the binary in the right location with the right permissions, and then enable the systemd service for it.
Cool, awesome. Meanwhile, Chris, thank you very much for recapping that. Could you invite me to the? Apparently, I lost connection to our shared.
Sure.
Yeah, thank you. Okay, great. Okay, cool. So this Cloud Init file, it is sort of pre-templated now. You saw that we added those Nomad underscore server and Nomad underscore server tag thingies in there. Yeah, exactly. For the auto joining and also the Nomad server count. We're now going to pass this Cloud Init file to a user data script. We're going to pass this file, or we're going to use this file as a user data script in the user data argument in the instance template. Those are a lot of words. But let's get back to servers.tf. And then let me take a look. By the way, I'm not sure if I'm in your session, Chris.
There we go.
There we go. Nice. Thank you. Awesome. So back in servers.tf, we're going to need to set the user data script. So let me go ahead and do that. We have a couple values we're going to substitute in there. User data. I think it's with a dash. Yeah. User data. We're going to use the file function. We're going to say path.module and then /cloud underscore init.yaml. Then comma, and then we're going to pass in some values. So one was the Nomad version, which we set was going to be on 1.8.0. One was the Nomad client. We're going to set that to false because it's not a client, but it is a server. So server, we're going to set to true. We had Nomad data center, which is, I would need to Google the value for that. And we have Nomad server count. Let's set it to 3. And Nomad server tag, which was the local we defined on the top here. Local Nomad server tag. Let me quickly Google the Nomad data center. What value we need to pass in there for Google Cloud?
Yeah, so it's really anything you want. It's just sort of handy for the scheduling algorithm. If you have multiple data centers or multiple regions, you can indicate to the scheduling algorithm where things need to run. Yeah, I think GCP is nice. We're running in GCP and in an EU region. If we ever end up in a situation where we have a cluster spanning multiple clouds or maybe even an on-premise environment, this really helps you to indicate what's where.
Okay, that's good to know. All right. Nice. So we have the instance template now, but without the instance template doesn't really do anything for us. We're going to use a regional instance group manager, like the path and cattle analogy that Chris told us earlier about. This is what's going to manage the cattle. It's the group manager, and it's going to spin up instances adhering to this template we just defined. So I'll go ahead and create Google Compute. It's a regional instance group manager, and we call it Nomad.
Yeah.
Oh, we call it Nomad servers. This is managing Nomad servers.
Yeah. So the The reason we're using a region instance group manager here is because we want a regional cluster, which means virtual machines are going to be distributed in all of the availability zones in this region, which is good for higher availability. You can also create a Google Compute Instance Group Manager resource, which is a zonal instance group, and then all of your VMs will live in the same zone. Sometimes there is a specific need to do this if you want the absolute lowest latency, or there's a certain machine type only available in a certain zone, these kinds of situations. But in general, I recommend to go for higher availability, and then a regional instance group is the best way to go.
Yeah. And am I correct that this is a beta-only resource, or did I just imagine that?
No, that is correct. It's not being released yet in the mainstream provider.
Check. Now, could you briefly explain what I'm doing with the update policy here?
Yeah, so in a managed instance group, virtual machines are being created and deleted all the time, really depending on whether you're scaling up, scaling down, whether your template changed, maybe VMs are being patched. There's all kinds of reasons why these machines could go away and come back. And you really want to configure, in case of Nomad, these values, because the default values sometimes don't really work well together with what Nomad expects to happen to a virtual machine. So for example, for the minimal action here, we're setting replace instead of updating in place, so that we're absolutely sure that the new VM is bootstrapped like a clean slate, and we're not running with lingering items on the VM, like containers that were there previously, ports being reserved, and these kinds of situations. So we're configuring all of this in the best way possible for Nomad.
Yeah.
And so we also want some auto healing policies, and that means that Google is going to health checks our virtual machines. We are also going to create some health checks later, which target specific ports of Nomad, and that tells Google whether the VM is actually ready to run as a proper Nomad client or server. And if it's not, it will be discarded from the group so that there's no traffic routed to it.
So, considering I have to specify the health check in the group manager, I'm just going to declare it up here.
Sure.
Health check. Interval. What should we do? Like 10 seconds for the interval?
10 seconds is enough.
Okay. I'll do the timeout to 10 as well. Healthy threshold 2. And unhealthy, I'll do 10. So we have enough time. I know that.
Yeah, we don't want these to be too high, because then servers are going to be popping off and on all the time. So we want some reasonable thresholds. We can always change these in the future if we're noticing that our VMs are being unstable.
Yeah. Now, I should know this by heart, but what port are we checking? I think it's 464. 464 is for TCP, 4647 is RPC, and I shouldn't be saying stupid things. Now let me Google this. Nomad ports.
Yeah, so Nomad, the binary accepts traffic on a couple of ports, which is 4646, 4647, and 4648. They're used for different purposes, for incoming traffic, but also for communication between agents on both TCP and RPC protocols. Something called chatter, which is how servers communicate to, for example, elect a leader. So we probably want to health check against one of these ports to make sure that not only is our server up and running, but also Nomad is properly up and running within there, because we still don't want to serve traffic to machines that are not running Nomad properly.
Yeah. All right. So a good path to health check again is the agent health check. V1.
Yeah, Nomad exposes a path V1 agent health that returns a 200 if everything's okay. So I think that's the perfect endpoint to health check against.
Yep. Okay. And I quickly Googled 464 is for HTTP, 4647 is for RPC, and 4648 is Surf1 protocol, which is, I'm going to read it out loud. This is used by servers to gossip both over the LAN and WAN to other servers. It isn't required that Nomad clients can reach this address. It's for TCP and UDP. I was not aware of 4648 before. I guess I never used it. Okay, so that's the health check. I'm going to reference the health check in here. Google Compute Health Check Nomad servers.it. And we're going to, next to the auto healing policy, we're going to create an auto scaling policy. Max replicas is, I know that min was going to be 3. What should we do for max?
Yeah, you always want 3 because you need an uneven number for proper leader election. And 1 obviously is nothing, right? If it crashes, you have nothing. So I think 3 is a good minimum number.
Okay, and how about the max replicas?
Yeah, so depends on how much money you want to spend, of course, because yeah, this scales up until Google runs out of servers. So it's a good strategy to set some kind of decent maximum. Yeah, I don't know, maybe 10 or 8, I don't know.
Okay, so 8, sure. Did I make a typo here or what? I completely did that incorrectly. I think we need to do a named port instead of the, I think the autoscaling policy is going to go into an autoscaler itself. Nomad. Oh, I'm bad with computers, I'm sorry.
Yeah, so named port is also a Google Compute Engine feature, and this sort of in the future allows you to target ports by name instead of having to remember what the number is.
Yeah. Okay. And we need that autoscaler, right? So this is the instance group manager. We're going to create an autoscaler. Why are we going to create the autoscaler?
And so by default, an instance group doesn't scale up and down automatically. And the whole point of a workload orchestrator like Nomad is so that if you add additional workloads, that you have space to put them. So instead of reserving like 10 VMs and running that fixed size cluster all the time, if you want to preserve some cost, it's a good idea to run, in our case, between maybe 3 and 10 VMs and scale up and down depending on how much you actually need. And in a cloud environment, that can significantly reduce your cost.
Yeah. So this is where I'm going to put in the min and max replicas.
Yeah, let's also put in that cooldown period that whenever a server is idle, it doesn't automatically get shut down because then you get a lot of variation in your scale, and that's not good for your stability.
Yeah.
So only after 2 minutes, because all of these values are in seconds, only after 2 minutes of not doing enough, like being of a utilization below 0.75, only then the server will be scaled down.
Yeah, exactly. And so we're using a plugin. This triggers me to one thing because we haven't thought about IEM yet. But there's, so we have a, if you go to IEM.tf, we have a simple Google Service account. It's called Nomad Agent that we're giving to, that we're passing into the instance group manager or template. So whenever you spin up a new instance, it gets a service account. Now, if we go back to the Cloud Init.yaml, we have this server join on line 25, 26, and 27. which is a plugin that we're installing. We're using the GCE Google Compute Engine plugin. I'm going to assume that it needs to be able to find other, or at least see other Google Cloud Compute instances. So I'm suspecting that we need to give some compute viewer permissions to the service account. Is that right?
You're absolutely right. By default, in Google, nothing can talk to anything else. Like it's closed off. So in our case, if the Nomad binary runs on our VM and this VM runs underneath a certain service account, we need to make sure that that service account is able to see the other VMs in the network, the other resources from Google. So for that, we need to create an IAM membership indeed. In our case, we only need our VM to be able to see which other VMs are there. They don't need to be able to change them. So let's give it indeed the compute viewer role and then associate that with the service account that we have created before. And this really allows Nomad on all these VMs using the service account to view the other VMs in our network.
Okay, awesome. So we have the servers.tf typed out. So if you go back to servers.tf, quick recap, we have a instance template which references that user data Cloud Init file that we created. We attach it to a network. We have we attach a disk to it, which is the base. Basically, the source image is an Ubuntu 2404 image. Sorry, that's the boot disk. We attach it to the network. We have a service account, which is that Nomad agent service account that we just grounded the compute viewer to. We created a health check on v1 agent/health. And we have a instance group manager that references the instance template, and it actually spins n, in this case 3, Nomad servers up. And then we have a regional autoscaler that makes sure that if one of the CPU, if the CPU utilization of one of these servers hits basically 75%, we spin up an additional Nomad server up to 8 replicas with a cooldown period of 120 seconds.
Yeah.
I guess.
Now that you're talking about the auto scaling, that reminds me of a fairly new Nomad feature called Autopilot. I don't think we have configured that yet in our Cloud Init. So maybe you should have a quick look at that.
Oh, sure.
Yeah, I don't see it here. So I can type it out for you if you want.
Go for it.
So there is a feature. This is pretty amazing. It gets auto-completed already by my IDE. So this is a feature called Autopilot. And this really sort of automatically cleans up stuff once it disappears. So in our cluster, if we're going to scale down, the VM is gone from our cluster. But Nomad still remembers that this VM existed at some point, and it will keep being in sort of a list as in an offline or disabled state indefinitely. And we don't want any management overhead in our case because we're working in the cloud. We have automatic scaling. Everything should be automated. So let's enable Autopilot and make sure that these dead servers are automatically cleaned up and removed from our list, so that we don't have to do any manual administrative work.
Good one. And I just noticed that we only specified a server block, but that we also need an equivalent of a client.
Yeah, so after the servers, we are going to provision the clients as well, of course.
I'll just add this in here. I think that should be it.
And let's pay some special attention to all the information. Because if this is not correct, then the file will not properly be parsed, and the servers will basically crash on boot.
Yeah.
So yeah, because this is all inline in our YAML file, this is sort of kind of a mess sometimes to automatically indent. So what I sometimes do is just grab this whole thing And then I create a temporary file like config.html. I put it in here, and then I can use my editor auto formatting to take care of it. And I grab this again, and we go back here and put it in. All right. Looks good. You are muted.
Oopsie, thanks. I was going to say LGTM, should we try to deploy it and hope that the demo gods are on our side?
Let's go ahead, open up the terminal a little bit. So
are you authenticated to Google Cloud already?
Let's find out. Terraform should tell us. So let's complain a little bit about a log file, and that is because we added this provider, right? So
yep, provider.
To run this upgrade, we install the Google Beta provider. Looks good. So it's complaining about an invalid function argument. So something is not correctly syntaxed.
We broke something. No. Let me check. Live debugging this. Love it. Let's see.
So it doesn't. Somewhere we referenced vars.gcp project, which doesn't exist.
Oh, really?
Not sure where.
Write var instead of. I can't find that.
Oh, it's actually in the Cloud Init file itself. So yeah, I see what's going on. What's happening now?
I think I definitely broke something. Yeah.
Oh, no.
No. I don't think.
There we go.
No.
Yeah, so this whole parameter is actually missing from.
Oh, snap. Okay.
From the input here.
Yep. Local.project. Yep. So I hope I didn't miss more. Okay, great. So it is refreshing all of the network bits and pieces that we deployed earlier and talked about earlier. FYI.
Yeah, absolutely. So it's going to install a bunch of stuff. We have 5 new resources, which we expect, which is the health check, the template, with all of the YAML embedded in here. So that looks good. You can also see that some of these values are automatically replaced because we're using the template file function. It's creating the Autoscaler, the instance group manager, and the IAM membership that we needed. So this looks pretty good to me. So we go ahead and apply this.
Yep, ship it.
Here we go. So sending this off to Google. We're going to create some templates and VMs. So this might take a little bit of time. So
mistake
we're referencing an image that doesn't exist.
Mistake by Bruno again. I thought that was. Oh, I already see what's wrong. It's a typo. It's fixed. I did cloud instead of cloud. Don't ask me why. Yeah, it's fixed now.
Correct. Ubuntu US cloud.
Yeah. So what I did, it was this previously cloud. I just hit a typo there.
I would think it's Ubuntu OS cloud.
Oh, it is OS cloud. Did I type US cloud? I didn't even see that. Okay, yeah. It's OS cloud. Yep.
Cool.
Nice.
Yeah, it's creating this instance template now. So wait a little bit for that. This can take some time because it's virtual machine stuff.
I got stressed out. All the
template is there.
Oh yeah.
Maybe you can already switch over to Google here and have a quick look.
Compute engine to see what was actually deployed after we ran that Terraform apply. So yeah, you can actually see 6 virtual machines here now. So let's have a look where they come from. So like we saw in our Terraform code, we worked with the managed instance groups. So let's go to the instance groups, and we see our clients and our servers instance groups right here. And you can also see that they come from the template we defined earlier. So if we dive into one of these instance groups, we actually see that it has 3 instances, that they're all healthy. You can actually see which those instances are. We can see that our health check actually works. So as a reminder, this actually checks whether the Nomad API health check endpoint is responding with a 200. It's not only checking the VM, but the actual app. So that's really cool. But we probably want to see if Nomad is properly configured, right? Because the first time you boot it up, you have all these things going on, like service trying to find each other and doing leader election. So where can we find this information? Well, this is all happening in our Cloud Init, which happens during boot. And all the boot logging of a VM is visible in the serial port console.
Nice.
So let's open that one up. And here we can see the entire VM from the very first moment it became online. So if you go all the way down, we should see some useful logging from Nomad. So here we can actually see that it found a number of peer servers, and it's going to attempt to bootstrap our cluster. It's doing the leader election, and it actually finished leader electing, and this particular VM actually was the acquired leader. So I think the bootstrap looks really good. So we have a healthy Nomad cluster now with 3 servers and 3 clients. Everything is able to find each other. So I think the next step should be to arrange some ingress for our Nomad administrative UI.
Yes, awesome. That's great. So indeed, I think our next step would be to set up like a load balancer, some ingress, have a nice admin.nomad, whatever DNS name we're going to set up, to be able to access that UI. Because looking at the logs is one thing, but I want to see a Nomad UI, of course. Cool. I think we're going to do that in our next episode, though. What do you think, Chris? Yeah,
it's getting quite long already, so let's do the ingress in its own little episode. Yeah.
Cool. Awesome. Then thank you everyone for watching. Chris, thank you very much for walking us through setting up Nomad on Google Cloud, and in particular with all these compute resources. So quickly to recap, we set up an instance template. We set up a instance group manager, which is using the template. We set up an autoscaler, which is making sure that we scale up to an amount of instances based on CPU utilization. I think Chris is pulling that up on the screen right now. We set up some health checks as well. What else did we set up? I think that's it, actually. Yeah. Cool. Awesome. Everyone, thank you for watching. We're going to see you in the next episode where we're going to set up ingress for the Nomad portal, Nomad UI, using a load balancer and DNS. So, Chris, thank you, and I'll see you in the next episode.
Yeah, see you very soon. Bye, everyone. Bye.